Hey peeps, what's up? It is Friday, November 10th, and I'm coming to you from Clark High School, getting ready to show you guys some more examples on how to graph these pesky quadratics. Let's take our first example, and let's say that we're asked to graph this thing, y equals -3 times, inside our parentheses, x minus 1 to the second power. Second power tells us that it's quadratic, plus 5. Okay. In class, I showed you guys 3 steps to graph these quadratics. And it doesn't matter if they're in vertex form, like we have in this one. This is in vertex form. Or if it's in standard form, the steps are going to be the same. The first step is to find what the vertex is. And in this problem, we're very lucky because the vertex is basically handed to us on a silver platter, more or less. Inside our parentheses, we have -1. We have to remember to take the opposite of that number, though. The opposite of -1 would be +1. The number on the outside, after the parentheses, is the second coordinate of the vertex, and that number you don't touch. If it's +5, keep it 5. If it's -5, keep it -5. That was pretty easy. We just had to find the vertex. Once we have the vertex, what we want to do now is get some more points, because 1 point isn't going to be enough for us to graph this thing. We need to get a handful of more points. And the way we do that is by creating a table of values centered at the vertex. And let me write this first. Step 2, make a TOV. Okay, TOV, table of values, with vertex at center. Okay, I don't have a lot of space, so I'm going to paraphrase. With vertex at center. And when I say at center, I mean the center of the table. You can do as many points as you want, but I recommend we do 5 points. And we already have one of those points, don't we? And what is that point? That point is the vertex. We already have it. I'm going to put that right in the middle, smack dab right in the middle. You guys liked when I said that, so I'll keep saying that. Smack dab in the middle. Now to get some more x's, going to the right of 1, do you remember what we're going to add? We're going to add 1, right? You could add 2, you could add 3, but why would you do that? Why would you make things harder for yourself? 1 is going to be the easiest number to use. It's going to keep our numbers reasonably small. This would become a 2 now. Add 1 again, we get 3. And what do you think we're going to do going the other way? Brilliant. Subtract 1. 1, take away 1 gives us 0. Take away 1 again, that's going to give us -1. Okay, now we need to find what these other numbers, -1, 0, 2, 3, what their partners are. And to do that, let me stick with the same color, sorry. To do that, we need to plug in these numbers into the function that we were given to find what its y value is, what its partner is. Now remember what I said, pick a side. It's like Twix, left side, right side, pick a side. It's kind of a trade-off. The left side you have 0, and that's always nice, but we do have to deal with this -1 if we choose the left. On the other hand, this other side, the numbers are a bit bigger, but they're all positive, 2 and 3. I still like to go, hey, what are you doing? Get out of here. Go. Go away. Oh, now you're starting up? Come on. This thing's been tweaking all day. Okay, I'm going to use the left-hand side of the table because I like working with 0. It doesn't matter that I have -1 there. I like working with 0, and I just have to deal with the negative. No big deal. What I'm going to do now is, let's do the harder one first. I'm going to plug in -1 into this function, and I'm going to find out what y is. So make sure I do it right. -3 on the outside. I'm plugging in -1 for my x, -1. Then we have to square whatever that ends up being. And then we have to do what? Add 5. All right, now what I'm going to do is I'm going to write things out one step at a time instead of crossing stuff out and writing. That might have been a little confusing when I was doing that in class, and I'm sorry if it was. -1 minus 1 is -2. All right? Follow order of operations. Parentheses, we just did those. -1 minus 1 is -2. Now we can square -2, and -2 squared is not -4, but +4, right? Because -2 squared means -2 times itself. -2 times -2 is 4. Okay. Moving right along here. -3 times 4 is -12. And if we add 5 to that, we get -7. Let's recap what we just did. We plugged in -1 into our function. We did all this mess here to get -7. We plugged in -1. Its partner ended up being -7 because that's what the function spit out when we plugged in -1. Now let's do the easy number, and that's 0. Okay, plug in x equals 0. In for x. Oh my god. Come on, get it right, Miller. Get it right. 0 minus 1 squared plus 5. All right, so let's do it. 0 minus 1 is -1. What's -1 squared? Please don't say -1. Please don't. Please don't. -1 squared is +1. And again, that's because -1 squared means -1 times -1, and that equals +1. All right, -3 times 1 is -3, and -3 plus 5 is +2. We plugged in 0 into our function. What spit out? +2. 0's partner is 2. That might look like a lot of work, and maybe in the beginning it's going to seem like it's a lot of work, but after you do, 100 problems or so, it's not going to seem so bad. Even after 100 problems, if it still seems like a lot of work, the good news is we get a little bit of relief here, don't we? We picked left side, and the good news is we actually already have the right side from the left. The first piece, first y value is going to match the last. The second y value is going to match the inner second, or the second to last, however you want to think of it. Okay? -1, -7, 3 is also going to get paired with -7. 0 is paired with 2. 2 is also going to be paired with 2. Now for step 3. Step 3 is graph your table of values. And when we oh my god. I'm just a hot mess today, aren't I? Let me do a better job of writing this. Step 3. Graph table of values on your coordinate plane. Let's start from the far left and go to the right. -1, -7. And I'm going to do this in red. So it's distinguishable. -1, -7, 0, 2. 1, 5. X is 1, y is 5. 2, 2. And then lastly, 3, -7. X is 3, Y is -7. All right, I am going to be bold and brave and try to connect these dots, but it's very, very difficult with this smart pen. But let me see if I can be a little swag here and get it to work. Eh. Okay, I gotta practice, don't I? Close enough, right? Close enough. Okay. And there you have it. That's how you graph a quadratic in Vertex form. Now, I want to point one last thing out before I end this video. And that is, because this -3 was in front of our quadratic, it is not a naked quadratic. I know that sounds weird, me using the word naked in math class. I'm sorry about that. But that's just the easiest way to explain it. You cannot use the trick of, oh, I'll use that original table. Remember when we were graphing the naked ones, -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. And what we would say is, okay, how is x going to change going from our original table to our new one? We would add 1, because we take the opposite of this number inside, to each x, and we add 5 to each y. Okay, we can't really do that here because of this -3 in front. And to make things easier on us, this 3-step procedure that I'm showing you is what we will always do. We'll find the vertex, we'll make a table of values, and then we'll graph the table of values. All right, there you have it. Quick, easy, simple, beautiful. Hope you guys have a nice weekend, and I will see you on Monday, and I hope you're finding these videos somewhat helpful and informative. Ciao.